Welcome to this session. Today we are going to discuss the combinations with the repetitions and the principle of inclusion exclusion. So here, combinations with repetition. Suppose we wish to select a combination of R subjects or objects from the set of n distinct objects with repetition allowed is C n plus R minus 1 CR. And here n is the number of distinct objects and R is nothing but the objects that we are going to select. So here this is the formula C of n plus R minus 1 comma R. So after simplification, this is equal to this. Either we can represent this or with this. So here, this represents the number of combinations of n distinct objects taken R at a time with a repetition allowed. So the same thing we can also express as R identical objects can be distributed among n distinct containers. So the same thing we are going to represent R identical objects can be distributed in n different containers. And the same thing also we are going to represent as the number of non-negative integer solutions of the equation x1 plus x2 plus and so on, xn is equals to R. Here n is nothing but the number of variables which are existing in the equation, and R is nothing but the right hand side of the equation. So we are going to represent C of n plus R minus 1 comma R can be represented in these two different ways. That means R objects can be distributed among n distinct containers, or there are number of non-negative integer solutions of the equation x1 plus x2 plus and so on, xn is equals to R. Or we can say that the number of combinations of n distinct objects taken are at a time while repetitions are allowed. So this is the formula that by using this we are going to solve some of the problems. So here a bag contains coins of 7 different denominations. Let us say a bag contains, there are 7 different denominations. Means let us take any way that we are going to consider. So here let us take 5 pi coins and the next 10 pi coins, or 20 pi coins, or next 25 pi coins, or 50 pi coins, or we can take 1 rupee, 1, 2, 3, 4, 5, 6, or we can take 2 rupees. So these are the different denominations, and each denomination will have 1 dozen coins. 12 coins will be there. Each denomination will have 12 coins will be there. So like this, a bag is consisting like this. Now here the question is, in how many ways we can select a dozen coins from the bag? In how many ways that we can select a dozen coins from the bag? So here n is equals to 7 different denominations will be there. So we have to consider n is equals to 7, and each denomination will have 12 coins. So R is equals to 12. So then we have to substitute in this expression n plus R minus 1. N is equals to 7 plus R minus 1 CR. So it is nothing but 18C12. This also can be represented as C of 18 comma 12. So which is equals to 18 factorial by 16 factorial, 4 factorial, 18 minus 12. So it is nothing but 4 factorial into 12 factorial. After simplification, we are going to get 18,564 number of ways. Then the another problem. Let us consider in how many ways can we distribute 10 identical marbles. 10 identical marbles. So R is equals to 10, and next among 6 distinct containers. So distinct containers means n is equals to 6. N is equals to 6. That means once again we have to say that then we are going to take it as n plus r. So 6 plus 10 minus 1 CR, C10. So it is nothing but 15 C10. 15 C10. So those many ways we can identify and we can distribute 10 identical marbles among 6 distinct containers. Next, another one. So here this is the equation is given. Find the number of non-negative integer solutions of the equation x1 plus x2 plus and so on plus x5 is equals to 8. So here n is equals to the number of variables which are existing in the equation 5, and r is equals to the right hand side value is 8. So then once again the same formula we can get 495. 495. So this is we have to apply, and n plus r minus 1 CR. Subsequently we can get 495. 495 ways. Now here the next problem. Find the number of distinct terms in the expansion of, so here it is given. How many distinct terms will be there if you are going to expand this expression? That is the final question. So how many distinct terms will be exist? So for that we are going to write by using multinomial theorem. So it is the coefficient of x to the power of n1, x to the power of n2 and so on, xn power tn as n factorial by n1 factorial, n2 factorial and so on, nt factorial. This we are going to represent in another form as n1, n2 and so on, nt. So the same thing, this is the coefficient of x1 to the power of n1 into x2 to the power of n2 and so on, xn to the power of tn. So here, by using this, we are going to write the same thing as like this. So here, we have to consider what is the n1 plus n2 plus n3 plus n4 plus n5 is equals to n. N is nothing but 16. N is nothing but 16. Subsequently, we can get a equation. So from this equation, we are going to find how many non-negative integer solutions of this equation. So here 5 variables will be there. N is equals to 5 and r is equals to 16. Once again, n plus r minus 1 and next c C16. So this is nothing but 20 C16, which is equals to this. So these are the direct problems which are related to the combinations with repetitions. Now let us consider, we go for find the number of inequality will be given. Suppose the inequality will be given x1 plus x2 plus and so on plus x6 is less than 10. So then we are going to convert this into an equation by adding another variable and that variable which satisfies this equation. That is nothing but 9 minus x7 is greater than or equals to 9, less than or equals to 9. Subsequently, we can add each and every. So here minus x7 is less than or equal to 0. So multiplying with minus, so x7 is greater than or equals to 0. That means whatever the variable that we are going to add, that is a non-negative integer. So the equation will become x1 plus x2 plus and so on plus x7 is equals to 9. And for this, how many possible solutions will be there? So the solutions are, we are going to get here n is equals to 7, r is equals to 9. Once again using the same formula, and 1 we are going to obtain these many non-negative solutions which are going to exist for this equation. For this equation. So it is less than 10. So we are considering as a next integer value as a 9. So, and we are going to add. So one more so the non-negative solution that has x7, and for that we are going to find the solution. Now let us go for this. Find the number of positive integer solutions of this equation, and subject to the condition. Subject to the condition. So this is the condition is given. x1 is greater than or equal to 1. x2 is greater than or equal to 1. x3 is the greater than or equal. So we have to find the solutions of this equation, provided the solutions are satisfying this condition. So whenever if it is given like this, then we have to write x1 minus 1 is greater than or equal to 0. x2 minus 1 is greater than or equal to 0. x3 minus 1 is greater than or equal to 0. Now we are going to take this as y1. So y1 is greater than or equal to 0. Then this I have to consider y2 is greater than or equal to 0. Then this is y3 is greater than or equal to 0. So now whenever any condition will be there, then the condition we are going to consider, and we are going to reduce the equation to another form. So how? y1 we are taking it as x1 minus 1. From this we can calculate x1 is equals to y1 plus 1. Similarly, y2 is equals to x2 minus 1. Subsequently, x2 is y2 plus 1. And next y3 if I am considering as x3 minus 1. Subsequently, x3 is equals to y3 plus 1. So these x1, x2, x3 I am going to substitute in this equation. So the equation is reduced to another form. And here the condition is y1, y2, y3 should be greater than or equals to 0. Should be greater than or equals to 0. So we are going to reduce the given equation to another form. The form is consisting new variables, and the new variables are all are non-negative integers. And if I am going to converting into the original problem, and the condition is going to be fulfilling this. And so we are going to find here how many variables are there. N is equal to 3 and r is equals to 14. Then by using this, we are going to simplify n plus r minus 1 cr. So by using this, we can get 16 c 14. So that is 120 positive integer solutions will be there, which are fulfilling the condition that x1 is greater than or equals to 1, x2 is greater than or equals to 1, x3 is greater than or equals to 1. Now the second one, this is also equation will be there, and another condition is given. Condition is different conditions are given. So this also we are going to consider it as x1 minus 2, which is greater than or equals to 0. So let us consider I am taking as y1 is equals to x1 minus 2. Then obviously y1 is greater than or equals to 0. So x1 is equals to y1 plus 2. This is for the first condition. And similarly for the next one, we are going to consider x2 minus 3, which are greater than or equals to 0. So for this, I am taking y2 is equals to x2 minus 3. So x2 is equals to y2 minus plus 3. So I am going to take this is x2 value is this, and subsequently y2 is also greater than or equals to 0. And the next another one is x3 minus 4 is greater than or equals to 0. So we are considering it as y3 is greater than or equals to 0. Subsequently, x3 is equals to y3 plus 4. And another one is x4. So what we are considering, x4 minus 2 is greater than or equals to 0. So this is y4, which is greater than or equals to 0. So we are considering like this. So what about x4 is y4 plus 2. And of course the last condition is x5 is greater than or equals to 0. We can take like this also, or else we can convert x5 is equals to y5. So y5 is greater than or equals to 0. So we just substituted all the values. What is x1 is y1 plus 2. This is x2. This is x3. This is x4. And this is x5. So subsequently, if you are going to substitute, then we are going to get the another equation which has y1 plus y2 plus y3 plus y4 plus y5 is equal to 19. So here n is equals to 5 and r is equals to 19. Then substitute C of n plus r minus 1, 5 plus 19 minus 1, CR. CR means then we have to consider 19. So C of this will become 24, 23, 19. C 23, C 19, which is equals to 88, 55. So whenever if you are going to find any number of positive integer solutions of any equation will be there with respect to the condition, then based on the condition, we are going to write the entire condition as the, then we have to take the right hand side inequality into right hand side to the left hand side. Subsequently, we are going to assume that is some other variable. Subsequently, so that variable will be greater than or equal to 0, means it is nothing but a positive integer solution. We are going to reduce to another form. Then we are going to find the number of non-negative integer solutions of that reduced equation. Subsequently, the given condition is automatically satisfied. Now let us go for the other example. See here, amount 1500 is to be distributed 3 poor students. Let us those poor students are A, B, C of any one class. So here, in how many ways the distribution can be made? Of course, it is a multiple of hundreds. So the question is, if every one of these must get 300, the first condition, and if A get at least 500, B and C get at least 400 each. So after fulfilling this, how many ways the distribution can be made? See, it is in a multiple of 100. So total number is 1500. So 15 multiples is nothing but 15 units. 15 units we have. So here the first one is, if every one of these, so the poor students A, B, C, everybody has to get 300 each. So 3 units. So total 9 units. So remaining units are 15 minus 9 is 6 units. So 6 units, in how many ways the distribution is going to be taken place? So here n is equals to 6, and next r is equals to n is equals to 3 candidates. So n is equals to 3 and r is equals to, so remaining 6 units or 600. So this is nothing but n plus r. So 3 plus 6 minus 1 c r is equals to 6. Subsequently, this is equals to 8c6. 8c6 is nothing but 28. So 28 ways the distribution can be made. That means the remaining amount is only 600. 600 we are going to distribute in 28 ways. 28 ways we can possible to distribute in terms of multiples of hundreds. Now that is the first one. And the second one is, A has to get 5 units, 500. B and C both are get at least 400 each. So now this is 13 units are left, exhausted. Then the remaining units are 15 minus 13, only 200 rupees. That is 2 units. 2 units we have to distribute. So here n is equals to 3, r is equals to 2. Once again, the same thing. N plus r minus 1, CR. So subsequently we can get 6 ways. We can get 6 ways. So 6 ways the distribution is possible in multiples of 100. In multiples of 100. So this is one of the problem. And another one is, how many ways can we distribute? Can we distribute 7 apples? Apples are 7 and oranges are, so here oranges are 6. How many ways can we distribute 7 apples and 6 oranges? So here the condition is given so that each child gets at least 1 apple. So the condition is imposed on apples only. There is no condition on distribution of oranges. So here there are 2 tasks, T1 and T2. Task 1 is distribution of apples based on the condition. Based on the condition. And task 2 is distribution of oranges. So here no condition. Here no condition. So now there are 2 tasks are going to be performed, T1 and T2 simultaneously. So by the product rule, how many ways that we are going to perform T1 into how many ways that we are going to perform T2. So this is nothing but the total number of ways that we are going to performing. The performing means distribute the fruits to the 4 children. Now let us consider the first one is, so the children are, let us say, A, B, C, D. Each and every child will have at least 1 apple. So 4 apples are exhausted. The remaining apples are 7 minus 4. 3 apples. So these 3 apples are going to be distributed among 4 children. So n is equals to 4, r is equals to 3. So the total number of distribution are which is equals to n is 4 plus 3 minus 1, 3. So it is nothing but C of 6, 3. This is task 1. And the next task, so there is no condition. There is no condition will be there. Oranges. How many oranges are there? 6 oranges are there. So here r is equals to 6 and n is equals to 4. The same thing. N plus r minus 1. So C of. So this will become C of n plus n is nothing but 4 plus 6 minus 1, 6. So it is a 9C6. C of 9, 6. This is T2. So the distribution are one after the other. It is nothing but the product. It is nothing but the product rule. So we are going to multiply C of 6, 3 into C of 9, 6. 9, 6. Subsequently, we can get a 1680. 1680. So the number of ways with this condition, the distribution of the fruits in 1680 ways they are going to distribute. So these are the problems which are related to the combinations with repetitions. Now we are going to discuss the another topic as the principle of inclusion exclusion. Principle of inclusion exclusion. So principle of inclusion exclusion. What is the principle for 2 sets A and B? What is the formula for principle of inclusion and exclusion for 3 sets A, B and C? A, B and C. So first let us go. Next after that, what is the principle of inclusion and exclusion for n sets? For n set. Let us concentrate first 2 sets, 3 sets. After that we'll go for n sets. Now, we have to consider any 2 sets. So the number of elements in the set A or B. So here, which is equals to the number of elements in A plus number of elements in B minus the number of elements in A and B. So here, this we have to calculate, this portion, the total number of elements in A, total number of elements in B, minus this one. We are going to get the total number of elements in A union B. This is the principle of inclusion and exclusion. Let us, we are going to define n of A union B, also taken as number of elements is nothing but the cardinality of the set A union B is equals to cardinality of A plus cardinality of B minus cardinality of A intersection B. So this is the principle of inclusion and exclusion. Principle of inclusion and exclusion for two sets. Suppose if I am going to consider for three sets, then number of A union B union C equals to number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B minus number of elements in A and C minus number of elements in B and C plus number of elements A and B and C. This we are going to write it as cardinality of A union B union C, which is equals to cardinality of A plus cardinality of B plus cardinality of C minus A intersection B minus A intersection C minus B intersection C plus cardinality of A intersection B intersection C. Because for solving the problems, we are going to use this kind of formulas that we are going to use while solving the problems. Now let us go for an example. A computer company requires 30 programmers to handle system programming jobs. So there are how many kinds of jobs will be there? There are system programming job and another one is application programming job. So here A is the set performing system programming jobs or number of employees or number of programmers who are related to the system programming. And B, if I am considering number of programs who are related to the application programming. So here two sets are given. Now see here the company requires 30 programmers to handle system programming. So that is a cardinality A is 30. Cardinality of B is 40. And the company appoints 55 programmers to carry out these two jobs. So cardinality of A union B, that is to perform these two jobs. How many they are recruited? 55 employees, 55 programmers they are going to recruit. Next, the question is, how many of these performs jobs of both types? Both types means A should be performed as well as B should be performed. This we have to calculate. Then another one is, how many handle only system performing jobs? So how many only system performing jobs? That is a cardinality of only say A minus B. So here A is this and B is this. A is this and B is this. So we have to calculate, this is a system programming, this is a application programming, then we have to calculate only this. Only this means cardinality of A minus B is how much? And next only this. So this is nothing but a cardinality of B minus A is what? A minus B means a set of elements which are in A but not in B. So now, first of all, let us consider, we have to calculate what is A intersection B cardinality. So for that, we have to take the addition rule as A union or principle of inclusion and exclusion. A union B is cardinality of A plus cardinality of B minus cardinality of A intersection B. So this I am going to write it as cardinality of A intersection B is cardinality of A plus cardinality of B minus A cardinality of A union B. So this is nothing but cardinality of A is equals to 30, cardinality B is 40, and the next 55, A minus B is 55, A union B. So 70 minus 55. 70 minus 55. So 15. So there are 15 programmers will be there. They are performing both the system programming jobs as well as application programming jobs. Now, the question is, how many programmers are allocated only to handle system programming jobs? So that is A minus B you have to calculate. What is the cardinality of A minus B? Cardinality of A minus B is nothing but a set of elements which are members in A but not in B. But not in B means as well as A and B. So here set up a cardinality of A. So some of the elements, some of the programmers, they can perform other job also. So excluding only this type of job, how many application system programming jobs only alone? So how many are going to be performing? So here this is a cardinality of A is, what is that? Cardinality of A is 30 minus A intersection B is 15. Subsequently we can get a 15. So 15 programmers can perform only the system programming jobs. And similarly, what is B minus A? B minus A is a cardinality of B minus cardinality of A intersection B. So that is nothing but 40 minus 15. So 25. So 25 programmers, excluding 25 programmers, are meant to do only the application programming jobs. So these are the problems under principle of inclusion exclusion for two sets. We are going to solve one more problem on two sets. So here in a class there are 52 students are there. In a class 52 students are there. 30 students are studying C++ and 28 students are studying Pascal. And another one is 13 students are studying both languages. 13 are studying both languages. How many in this class are studying at least one of these languages? One question. At least one of these languages means anyone, either C++ or Pascal. How many of these are studying neither of these two languages? That means we are not. None of them are studying C++ and Pascal. Let us. We are going to consider A is the set of all students who are studying C++, and B is the set of all students who are studying Pascal. So here in this way, cardinality of A is given as 30 and cardinality of B, which is given as 28. And next, both are studying. How many? 13 were studying both. So A intersection B, cardinality of A intersection B is 13. So 13 students are studying both. Then we have to calculate what is at least one of these two languages. So it is nothing but A union B. So cardinality of A union B. This is direct. Cardinality of A plus cardinality of B minus A intersection B. So it is nothing but 30 plus 28 minus 13. So which is equals to 45. So this is the first part, and the next one is none of them are studying neither this C++ nor Pascal. This is we are going to calculate A union B whole complement. A union B whole complement, that we have to calculate. So now A union B whole complement is nothing but the universal set minus A union B. A union B, it is nothing but the complement of A. So if I am considering A, this is the universal set, then A complement is nothing but this is. So it is nothing but U minus A. U minus A. That is the set of all elements which are members in universal set but not in A. Not in A. So we are going to write like this. So here the total number of students are 52 minus A union B is 45. Subsequently, we can get 7. So 7 students they are not taking C++ as well as Pascal, but either C++ or Pascal, there are 45 students are taking these 2 courses. So this is the problems related to the principle of inclusion and exclusion for 2 sets. In the next class, we are going to discuss the same principle for 3 sets and more than 3 sets. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.